Okay, this is a video just to follow up on what we did at the end of class today, so that on your own you can try and work through the different problems that you might have run into getting this program up and running. Now, I'm not asking you to turn in anything to demonstrate that you got this to work, but I'm going to assume that you're able to do all these steps and that you've seen what you needed to learn in these steps, because as we go on, it's going to build on it. So let's start there. So the first thing that I wanted you to do was to try and translate your name into decimal notation so that we could see how bits in different contexts get interpreted differently. So I'm going to do that here with Patterson. And what I'm going to do is I'm just going to create a scratchpad note here, and I'm going to look down in my preview pane, and I'm going to see if I can find the P, capital P, so that's going to be 80, and then a lowercase a is going to be 97, and then T is going to be 116 and 116, and TE is 101, R is 114, S is 115, SO 110, and Pat, let's see what I do. It should be P, A, T, T, E, 101, E, R, S, O, and then lastly N is going to be 110, sorry, 110. All right, O is 111, N. All right, so there we go. So that's my letters in decimal. So we're going to keep that on standby here. This was from our lecture slides, which should be online shortly if they're not already. So I'm going to close that for now. And the next thing that I'm going to do is I'm going to log into WCP Neal. So in order to do that, what I need to have a way to connect. And so the way that you connect is with a program. And on a Mac, what you can do is you can open a terminal window. And sorry, this isn't part of the terminal window. This is part of my setup. Sorry. Ugh. Okay, so I've opened a terminal window by going to Spotlight and running terminal. Terminal is located under Application and Utilities if you need to find it. Another thing that you can do is if you're on Windows is you can install the application called PUTTY. That's a Windows-based client for doing what I'm going to do in a terminal in Mac. The other thing you can do is you can go to the Chrome browser and you can install the Secure Shell client from Google by going down here to the web store, installing the secure client. Make sure it's the thing from Google though, because it's a security problem if you don't. Install it from the web store, and then once you've done that, you should have it show up in your applications, and you can connect the same way as I'm going to do in SSH. So just to show you both of those, so I'm going to connect to WCP Neal using my username. So your username is going to be whatever you turned in the quiz with a 45 at the end of it. Then your password is your same thing, username with a 45 on the end of it. So let's do that. I'm going to log in with my username, which doesn't have a 45. WCP Neal, KNEEL.westmont.edu. Got to spell Westmont right. And you're going to be, I guess I'm being asked for a password too. Type in my password. And now I'm on WCP Neal. So anything I type in the terminal now is going to reflect what's happening on that computer. So the first thing that you should do is you should change your password by typing in PASSWD and change it to something that you can remember but that other people in the class won't know if they find out what your username is. Okay. Once you've done that, you're logged in SSH through a terminal. If you want to do it through the Google Chrome plugin, you can do the same thing. It's just that you type dpatterson at WCP Neal here, you hit connect to connect, and then it'll drop into a terminal window that's running inside your browser. Same password should work, and you'll log in the same way. So since those things are both the same, up to this point, I'm going to go ahead and close my browser window and just work in my terminal. Okay, so now in my terminal window, the first thing that I have to do is I have to create a new file. So if you want to see the files that are in the directory that you're currently at, you can type ls and you'll get a list of your files. If you're new to the system, you'll type ls and nothing will show up. The next thing I'm going to do is I'm going to edit a program. So if you know how to use VI, you can use VI to edit a program. You can actually use Emacs to edit the program too, if you know that. But a more straightforward editor is called Nano, and Nano works kind of with arrows and just typing. It's pretty straightforward. So I'm going to use VI. I'm going to enter a hello world program.c. I'm going to edit it, and I'm going to type in the code that we need in order to get the program to work. So it's hashtag include less than stdio.h greater than int main printf string hello world exclamation mark. I'll put a /n on the end so that it goes to the new line, semicolon at the end of the line, curly braces at the end. That's my basic program. And then I'm going to save it. And when I save it, I can now run the program GCC on it. And if I do GCC-O, that tells me what I want my executable file to be named. Call it hello world. And then the file that I want to compile, which is hello world.c, and hit return. If I don't have any errors, then it'll compile fine. If I have problems with my text, I'll get an indication of what line the problems are on. I'll have to go back into the file, fix it, and then run that line again. But now I should be able to run hello world by doing a period, a slash, and hello world. That tells it which copy of hello world to run, and it's the one in the current directory. When I run it, it prints out hello world. So that's the first thing that I want you to be able to do, is to be able to type hello world like that. Have a program that writes hello world. Then I want you to go back into the program. Sorry. I want you to change it, and I want you to change it so that after hello world you print out the characters in your name. So %C is a character format token. Put a space between it and 1 for each letter of your name. So for me that's PATTERSON. New line character, double quotes, and now I'm going to put each one of my characters of my name individually after this to fill into the character format code. So a single quote means it's a character. So PATTERSON. Okay. Save that. Compile it and run it the same way. And now when I run hello world, it prints out the letters in my name. The last step is I want you to add one more line. Oops. I want you to add one more line to that and change the C's to D's. Actually, this isn't quite the last thing I want you to do. Now if you run it, compile it first and then run it, you can see that each one of those letters, those characters, are being interpreted now as integers. So when I look at my program, you can see here that the P is still a character, but rather than being interpreted as the bits being interpreted as a character, we're writing it out by interpreting those zeros and ones as an integer. The output then becomes 80, 97, 116, 116, 101, 114, 115, 111, 110, which, as you remember over here, should be what we got from our table. 80, 97, 116, 116, 101, 114, 115, 111, 110. So you can see that there's a standard way of translating those same bits into integers or into characters. When we ran our GCC program, in class we talked about all the different stages along the way of the program that's created, the assembly language and the binary. The program that we ran, that line with GCC right here, it does all those stages, but it deletes the intermediate products. One thing I want you to do is I want you to go through the steps of seeing those intermediate products at least one time. And so let's do that quickly here. Okay, I paused the video to go get the commands that we're going to run, but I'm going to put them over here in my scratch pad. So back here in our in the program where we're running, where we had hello world.c, the first thing that we can do is we can pre-process it. And so to do that, we can run the command gcc-E, give it an output file that we would like it to be named, hello.I, and then the input file, hello.c. that will do just the step of the compilation process, which is the preprocessor. Now we can look at what got output using the more command and spacebar, and you can see that our program got translated or got preprocessed so that the include stdio.h was replaced. We still have our program way down at the very bottom, but it's been drastically changed. All right. So the next thing that we can do is we can take that program and we can take the same program and we can output the assembly language code. So if I list my programs, we can see that sorry. So like I guess, all right, I didn't do that quite right. Let's see. Let's go back for a second. I'm going to remove hello. That's a different program. Hello.c. Hello.I. Us. Look at the files that are hello world. Okay, let me try that again. So I'm going to take hello world.c and I'm going to pre-process it. So I'm going to run the GCC program and use the option 'E. I'm going to say I want it to output it to hello world.I and the input is hello world.c. And now if I look at the pre-processed version hello world.I, I can see that hashtag stdio.h has been replaced. A lot of stuff. But down at the very bottom, we should see my original code. And it looks good. All right, so that's the first step, the pre-processed version. Now let's translate that to machine language by running gcc to assembly language, sorry. gcc-s. Our output will be hello world.s. Our input will be hello world.c. And now if we look at hello world.s, we can see the assembly language code that is the low-level machine language code that is the commands for the chip. And this is still in a text format. The last thing that we do is we translate that text format into a binary format with the object code. And so we can do that same process, GCC, create the object code, put it in a file called hello world.o, hello world.c. And now if we look at hello world.o, that's the next step where we've translated the assembly language into machine language, but now it's not a text file, so it doesn't get in, we can't print it out in a text format. In fact, the shell won't let you do it at all. And then finally, if you go all the way, you do GCC and sell it to do all the steps along the way, output it to hello world as the executable, and use hello world as the input, you then get the program that we just saw. Okay, so these are the steps that you need to be able to do in order to feel like you've learned what you need to learn from the lecture today. They involve logging on to a machine remotely, editing a C file remotely, writing the C code, compiling the C code to an executable. And the bonus stuff is to look at those intermediate products. We'll look at those in more depth later. Okay, thank you for your attention. Good luck. Use the Canvas announcement forum or to try, if there's any questions, we can sort of work through what they might be. All right, thanks for your attention.